Stop scrolling. This tiny pixel rewrites the first chapter of the universe. If this blows your mind in 5 seconds, you are about to time travel for real. Imagine you could travel back in time. Not with a machine, but with light. Imagine standing at the very beginning of everything, just after the universe was born in a flash of light. The air around you, if there was any, would be a thick fog of hydrogen gas. It is dark, it is quiet. Then, a tiny pinprick of light appears. It is one of the very first cities of stars ever to exist. This is not science fiction. This is a real journey we can now take. We are looking back 13.5 billion years to when the universe was only 2% of its current age. Our time machine for this incredible journey is the James Webb Space Telescope, or Webb, the most powerful space telescope ever built. It is a marvel of human engineering, designed to answer some of our biggest questions. Where did we come from? How did the universe begin? To find answers, Webb sees infrared light, invisible to us, rich with the oldest secrets. As the first light crossed billions of years, expansion stretched it from visible into infrared. Webb's giant golden mirror is like a bucket collecting faint ancient photons, and Webb carries a suite of instruments. Two were critical for this discovery, NIRCam and NIRSpec. NIRCam, Webb's eyes, takes ultra-sharp deep pictures. It first spotted MoM-z14 as a tiny, reddish dot among countless galaxies. These are dropout objects. They vanish in bluer filters and appear only in the reddest ones, a sign of extreme distance. Then NIRSpec, the spectrograph, breaks the light into a spectrum, the object's fingerprint. Together, NIRCam and NIRSpec turned a candidate into the confirmed most distant galaxy ever seen. The search for the first galaxies is like looking for a needle in a cosmic haystack. The sky is vast and these objects are incredibly faint. We pored over Webb's deepest images, scanning massive fields of data, covering an area of sky about 10 times the size of the full moon. We hunted for specks with the right signature, bright at long red wavelengths, and gone in the bluer wavelengths, a telltale of extreme redshift. In April 2025, a few candidates popped. One stood out. Unusually bright. We named it MoM-z14, Miracle of Miracles, with an estimated redshift near 14. But a red dot could be a dusty nearby galaxy. We needed its spectral fingerprint, so we pointed Webb again, not for a photo, but for a spectrum. When the data arrived, there it was, clear as day, a sharp Lyman break and 5 emission lines, the smoking gun. When we confirmed MoM-z14, we realized it was truly special, not just another distant galaxy, a puzzle, brighter, more complex, more mature than expected. At 280 million years, theory predicted faint, tiny proto-galaxies just assembling. Instead, MoM-z14 blazed, over 100 times more luminous than models suggested. Like a baby with a full beard, it doesn't fit our timeline, and it's part of a trend. Webb keeps finding surprisingly bright early galaxies. Then came another shock. NIRSpec showed strong nitrogen, not a simple hydrogen-helium relic, a chemically enriched galaxy. Its light escaped the early hydrogen fog, implying young stars carved a clear bubble, reionization in action. MoM-z14 may show one of the first tiny bubbles that transform the cosmos. So much nitrogen, so soon. A timeline problem. Today, nitrogen builds over many generations. Stars are born, fuse, explode, seed the next stars. That process takes billions of years. The Milky Way had over 13 billion years. MoM-z14 had only 280 million. Growing a redwood in a week, that's how off our timeline looks. One idea, the first stars were monsters, population 3, hundreds of solar masses burning hot and brief. Their furnaces could forge nitrogen efficiently, then explode, enriching gas rapidly. Another, MoM-z14 formed in an exceptionally dense region, gas funneled in fast, triggering starbursts at triple speed, many stars born and dying in quick succession. Likely both factors worked together to build a chemically evolved galaxy so quickly. To see how strange MoM-z14 is, compare it with what we know, the Milky Way. About 100,000 light-years across with hundreds of billions of stars. MoM-z14 is tiny, roughly 240 light-years wide. You could line up 400-plus MoM-z14s across the Milky Way's diameter. It's uber-compact, more like a single dense neighborhood than a sprawling city. In mass, MoM-z14 is comparable to the Small Magellanic Cloud, a dwarf galaxy orbiting the Milky Way. But for its size, it punches way above its weight, astonishingly bright. That brightness signals a furious burst of star formation in a tiny volume. Its chemistry is unusual too, nitrogen high relative to carbon, reminiscent of some Milky Way globular clusters. Those clusters are ancient fossils. The shared signature hints at similar early processes. MoM-z14 may mirror the building blocks that seeded our own galaxy. Extraordinary claims need extraordinary evidence. MoM-z14 began as a NIRCam dropout, but dust can mimic that. So we use NIRSpec to get the spectrum, the most powerful distance test. We looked for the Lyman alpha break, a cliff where neutral hydrogen erases bluer light. Its position gives the redshift directly. Ours landed at 1444. Then, the clincher, 5 emission lines, including nitrogen, all shifted by the same factor. The odds of that pattern by chance are astronomically small. We published in the Open Journal of Astrophysics with images, spectra, and analyses for the community to verify. Peer review and independent checks put the discovery on solid ground. Result: the farthest known galaxy, confirmed at the dawn of time. MoM-z14 and others like it are changing more than records, they're changing our story. For decades, models pictured a slow build-up to the first galaxies, tiny faint systems merging slowly over billions of years into giants like the Milky Way. Webb shows that picture is too simple, maybe plain wrong. The universe was more active, much earlier than we thought. As Jacob Shen said, there is a growing chasm between theory and observation, the best place for discovery. We may need new ideas about first stars, black holes, and rapid assembly. Maybe star formation was far more efficient, producing massive stars at scale. Or early black holes grew quickly, turbocharging their galaxy's light. We're explorers on a new shore. The old map misleads. Time to redraw the first chapter. So, what happens next? MoM-z14 isn't an endpoint, it's a doorway. We'll survey wider to build a census of the very young universe. Is MoM-z14 unique, or just the tip of an iceberg of bright, chemically rich galaxies? Dozens, then hundreds, will reveal what's typical, and what's rare. We'll compare sizes, shapes, and chemistry, including that strange nitrogen. JWST is poised to push the frontier to previously unimaginable redshifts nearer the first stars. We'll hunt for pristine population 3. Third stars. The first fire of the cosmos. MoM-z14 is a candle in vast darkness, a message in a bottle traveling 13.5 billion years, and that message is clear. There is so much more to discover. Our journey back to the dawn of time has only just begun. Light takes time. The sun you see is 8 minutes old, Proxima Centauri, 4 years old. Farther in space means further back in time. As space expands, light stretches. Its wavelength lengthens, like a drawing on a balloon. Blow it up, everything stretches. Distant light shifts to redder wavelengths. We call this redshift. Measure the redshift, measure the distance. MoM-z14 lands at 1444. That's about 280 million years after the Big Bang, closer to first light than anything confirmed before. A new distance record, and a new cosmic challenge. Seeing this ancient light is like unearthing a lost city, a direct glimpse of a forgotten era. On May 16, 2025, Webb captured light from MoM-z14. This light began its journey when the universe was an infant. NIRSpec confirmed a sharp absorption break and 5 ultraviolet emission lines, including nitrogen. The redshift, 1444 plus 0.02. Light stretched by a factor of 1544 since emission. Published in the Open Journal of Astrophysics, adding to a growing list of unexpectedly luminous early galaxies. As lead researcher Rohan Naidu put it, with Webb we see farther than ever. And it looks nothing like we predicted. JWST now seems poised to push to even earlier times, toward the era of the very first stars. MoM-z14, brightest, more compact, and more chemically enriched than expected at cosmic dawn. Found by NIRCam, confirmed by NIRSpec at Z-bar run 1444, just 280 million years after the Big Bang. Nitrogen enrichment and cleared hydrogen suggest fast, powerful early star formation. Data now lead the way, forcing new ideas about first stars, black holes, and galaxy assembly. We will keep pushing the frontier. If you want to witness the next first light, stay with us. 1 pixel. 1 message from the dawn. So much more to discover. Enjoyed this? Please like, comment, and subscribe for more fascinating content.